going to start the lecture on chemical engineering, nanotechnology in chemical engineering. So today we will discuss about different type of nanomaterials. So that already you have prepared. So that application particularly on the biofuel production. So in the content we will discuss what are biofuels, a role of nanomaterials, that is metal oxides, carbon based nanomaterials, that is for biofuel productions, and that nanomaterials will be applicable for the productions of biohydrogens by considering dark fermentations methods, photofermentation method, and integrated dark and photofermentation method, and sometimes photocatalytic reactions by using those nanomaterials for biohydrogen productions from biomass or the solid waste that we can use, that can be converted into biohydrogen productions. Also biogas production. So for anaerobic digestions, there we can use different type of nanomaterials, so that can be used to enhance the biogas productions, particularly methane rich gas productions. So also the nanomaterials that would be used for biodiesel productions, that is also biofuel from different oils, so edible oil, non edible oil. So how that can be converted into biodiesel, that would be discussed by using nanomaterials, and also bioethanol productions, that will be discussed. Also various factors that would affect the performance of biofuel productions process, so that will be discussed. So in biofuels, actually that is the renewable source of energy. So in this case actually we are not using fossil fuels. So in case that for that, so we are using different type of waste biomass, that may be edibles, non edibles, or biomass that is disposed to the environment, that would be used by different chemical process, that would be converted by using different type microorganisms, basically to convert a valuable renewable energy, that in terms of hydrogens, biogas, or biodiesel, or bioethanol. So there's that performance or the rate of productions or efficiency that we can improve with the help of nanoparticles. So using different type of nanoparticles, that may be metal based nanoparticles or maybe metal oxide based nanoparticles, that can be used to increase the high quality biofuel productions. So here global demand of primary energy consumption, that is fossil fuels, that is day by day increasing. At the same time the demand for biofuel productions also, or biofuel consumptions also gradually increasing. So here, so when we are using different type of fossil based fuels, so then the CO2 emissions also gradually increase. So here you can see, so from 2000 means 1990 to 2021, so that CO2 emissions by using fossil fuels, so consumptions of fossil fuels, the generations of CO2 gradually increase day by day. Therefore biofuel energy productions also, that is also increasing. At the same time, so globally also biofuel consumptions also, that is also increasing day by day. So and biofuel market is also, if you look into 2025, so that is approximately 1.141 USD billion USD dollars, and we are expecting 2030, so that would be increased to the 201 billion USD dollar. So that biofuel market is also gradually increasing. So at the same time the technology also, nanotechnology means the nanotechnology market, that materials that earlier used to produce very low quantity or less amount. So you can see it is producing that amount, and it is expected at 2030, so 300, approximate 300 USD billion USD markets, that would increase. So here's the source of biofuel production. So that may be wood chips, animal waste, crops residue, pellets. These are the different waste materials that can be used for the biofuel productions. The biofuel usually produced from primary biofuels, secondary biofuels. In primary biofuels, that is produced from different plants, forest waste, animal waste, crop residue, that can be used to produce different biofuels. And the secondary biofuels, where biomass feedstock with microorganisms that would be digested in any reactor, so that can be produce different type of biofuels. So here that can be also divided first generation, second generation, third generation, and fourth generations also. In first generation, so different type of corn, wheat, so sugar canes, barley, these are the edibles, or sunflower oils, so edibles crops that can be used, or that used to use to produce the biofuels. And in the second generations biofuel production, so there's different type of biomass residue, lignocellulosic biomassic residue, that are used to produce the biofuels. And in third generations, different type of microalgal species, microalgal biomass that is used for the productions of biofuel or biofuels. And in fourth generations, different type of genetically modified plant biomass that are being used for the productions of biofuels. Okay. So in now we know that different type of biofuels, that biohydrogen, biogas, biodiesel, bioethanol, so that would be used, and for that we will use different type of nanomaterials or nanoparticles to improve the rate of productions or performance of that particular process. So here different type of nanomaterials I said already. So carbon based nanomaterials, magnetic nanomaterials, metal oxide nanoparticles that can be used for that production. So in usually if you talk about the biohydrogen production, so that for that a different type of process, means dark fermentations process that basically used. So in that case different type of microorganisms that can be used, so that would be break down the organic molecules that is being charged inside of the reactors in absence of oxygen, that converted into small molecules, that is hydrogens, that would be produced, and with that volatile fatty acid alcohols that also would be produced at the same times. So in biogas, hence that biomass or bio that would be decomposed in absence, this is also biochemical process. So in here anaerobic digestions, here a specific type of fermentations process this is. So in this process the gases that would be produced, particularly methanes, that consist of methanes and CO2, and some component H2S is also present in this particular process. In this particular process means when we are going to produce methane rich or CO2, means biogas production. So that depends on that by this process, particular substrate concentrations, pH, temperature, organic loading rate, and hydraulic retention time. So if we change the retention time, the process different product variations also will be changes. At the same time biodiesel, so that also we can produce by using different type of non-edible oils, so that to convert into the biodiesels, and bioethanols that is also produced from the feedstock. These are the materials we can, waste materials we can use for production. So here's the, if we talk about biohydrogen production, so usually the process actually produce the hydrogen. So that means the process of hydrogen productions that sometimes is very low. So that may be due to the on that process some inhibitory compounds formations that actually prevent the metabolic process, and therefore so the productions of hydrogens that is decreased. So it also there are some side reactions, so means reactions is also going on. So as a result, so the whatever the hydrogen that is being produced, that would be the concentration should be decreased. So I will discuss those things. So even various inhibitory compounds that is consumed the hydrogen, what are the being produced, that produced hydrogen being consumed by the bacteria or nitrate reducing bacteria or volatile fatty acid formations that which are being formed during this digestion process of biomass. So as a result overall the rate of productions of hydrogens that what we are expecting, that would be a decrease. Okay, so means overall yield would be low. So here so you can see the means role of nanomaterials, means basically it acts as a catalyst. So here biomass, if we use conventionally microorganisms, that we can get biogas that would produce low conversion. So hence with that microorganisms, if we use some nanomaterials, that may be nanometals, metal oxides, so then the conversions would increase. So here's how the nanoparticles actually enhance that rate of productions of biofuels. So that actually the nanomaterials or nanoparticles that used in the bioreactor, that is anaerobic digestions, there's it acts as a catalytic agent for the microorganisms. It alter the oxidation states, means initially if we use let's say zero valent metals, irons let's say, so during reactions, so it would be converted into iron plus 2 or plus 3. So by that way, so these nanoparticles alter the oxidation state at the same time, so it would generate more hydrogens. Also it promotes the electron transfer, allows various type of reactions that occurs during the digestion process. Also the nanoparticles whatever we are using for this particular bioreactor or bioreactions, so there's it having extremely high surface area, means large surface area to volume. So that also assists for the microorganisms to bind to the active surface sites. So as a result, so more number of microorganisms may be distributed and digestion process would be enhanced. Also metabolism, it nanoparticles favor the metabolisms for various microbial communities. So here's classifications means the nanomaterials already have discussed different way it can be classified: carbon based nanomaterials, metal based nanomaterials, semiconductor based or nanocomposite based nanomaterials that can be classified. So here mostly for this particulars biofuel productions, metal based nanoparticles, that is actually good for that would improve the microbial growth and protein synthesis at nitrogen metabolism. So as a result biofuel productions will enhance. Or here's for example silvers or gold nanoparticles that we can use for the improvement of the substrate utilization capacity. Also these gold and silver nanoparticles that allows better adherence of microbial cells to activate active sites. Also it increase the enzymatics activities also. Here's example 2. So metal oxides, nanofiber nanoparticles that also improve the microbial growth. Also it increased both esterifications, transesterifications reactions for the biofuel productions. Here CNT also we can use, that also enhance that enzymatic reactions. So here's that factors affecting the nanomaterial synthesis for biofuel production. So nanomaterials, so usually that is 1 to 100 nanometers within that range. So whenever we are preparing that nanomaterial, so that nanomaterials we can prepare different methods that already have discussed. So also the during synthesis it would affect the temperatures, pH, pressures and particle size concentrations. So based on that different range of sizes nanomaterials would forms, and each type of nanomaterials, so that would affect for that particular biochemical reactions. So depending upon this particular process that nanomaterials we are synthesizing, if we go for any others method, so there maybe that materials may be much more effective. So here's chemicals routes, physical route, biological routes, any routes we can follow for the productions of nanomaterials. So most of the cases it is chooses the biochemical process or biological process that is most commonly used, and it is much more effective. Okay, so here production temperature also I said. So the nanomaterials will produce maybe high temperature or maybe low temperature. So in case of the physical or chemical methods, by that way if we prepare nanomaterials, so there we have to sometimes have to use high temperatures, and if it is biological method, so room temperature to 100 degrees centigrade, within that low temperatures we can prepare that material. So as a result the particle size would be very small, so that would be much more effective for that particular biochemical reactions. So also productions pressure, so hence we prepare the nanomaterials, so the pressures means synthesis pressures also that would affect the particle size, shapes, aggregations of that quality of nanomaterials. Also the productions pH, so depending upon that pH, either it is acidic or basidic, so based on that also nanomaterials whatever we will produce, so that would affect that overall performance of that biochemical reactions. So here's first we will discuss about the biohydrogen productions. There's we can use nanomaterials. So in biohydrogen productions there are so many process or methods are there. So I said dark fermentation process, by that way you can produce the biohydrogens. Photo fermentations, so in dark fermentations usually the amount of hydrogen is produced that is very low amount, so that is 4 moles of hydrogens per mole of glucose. So if glucose is the substrate, so in photo fermentations usually little bit better, so where light is also used with the nanomaterial, so therefore rate of productions is more by considering different other side reactions also is possible. And both the dark and photo fermentations we can use, that is called integrated methods for biohydrogen productions, that is dark. In dark fermentation process what are the materials will be left, that effluents that again should be charged into the photo fermentation process. By that way we can get more amount of hydrogens. And also photocatalytic reactions, that also we can use different type of nanomaterials, titanium based nanomaterials or others photocatalyte that acts as a photocatalyst. So if we insert different UV or photo visible lights during reactions, so then that would degrade the waters means hydrolysis and then increase the hydrogen production rates. So here you can see one reactors that we can use, so that is the dark fermentation process. Here hydrogens we can produce. So here different organic waste we can use, and by considering different reactions that may produce either acetic acid, butyric acid, propionic acid or ethanols that may be produced. With that, hydrogens also is produced. So, in this process usually I said in dark fermentation process the amount of hydrogen is being produced, so that is very less amount. So, it is actually independent of light this process, and usually we use microorganisms and nanoparticles. So, these microorganisms, clostridiums, deuterium, we can use for this process. Also different other different nanomaterials, that is silver, zero valent ions, iron oxides, ferrosulfuric oxides we can use, or SBF15 silica, nickel nanoparticles or nickel graphenes. These are the different nanomaterials you can use. So, depending upon the specific nanomaterials, the rate of productions of hydrogens that would change. So, here in dark fermentations process I said, and these are the various nanomaterials we can use, and these are the anaerobic, this is anaerobic digestion process. In this process hydrogens we will produce, and also the substrate is not completely utilized in this particular process, leaving behind large amount of effluents that are left in that reactors. Okay, so that we can consider as a organic waste. So, in dark fermentations process, these are the various reactions it may possible. So, overall these reactions. So, by this way, so hydrogens we can get by considering this type of reactions. So, role of different nanoparticles here you can see, for example. So, if we use silver nanoparticles, so then means without using silver nanoparticles in the digestion process from glucose, then if you use silver nanoparticles with and without silver nanoparticles, so it has been observed that when we use silver nanoparticles for this dark fermentation process, so glucose conversions that has been increased to 62%, and bio yield also that is also increased. Even zero valent ions also we can use as a catalyst or nanomaterial. So, for this dark fermentation process, so in this process also it induced more efficient biohydrogen productions by promoting the activity of biohydrogens producers, means these enzymes species. Some others nanomaterial, iron oxides, nickel nanoparticles, SBF15 also we can use, iron oxides, Fe3O4, encapsulated silica nanoparticles that also we can use. These materials is very effective for this particular dark fermentation process. So, here this nanomaterial synthesis process is there. So, I am not going to discuss more details on that. Okay, so how that can be prepared by step 1, step 2, step 3. So, already that has been discussed during nanomaterial synthesis or silica encapsulated iron oxide preparations. So, next step is the photofermentation process for biohydrogen production. See, here we have to take biochemical cells. So, there we can use the biomass, that is our effluent that is coming out from dark fermentation process, that we can charge it here. Here we can put the lights. Okay, in the process is dependent on lights and different type of nanomaterial, that is silica or iron zero valence metals we can use. So, also in this particular process acetic acid, butyric acid, propionic acid that would forms in the dark fermentation process that would come here, and those materials will be decomposed here in presence of lights and nanomaterials if we charged. So, then that would gives hydrogens in this particular process. Okay, so here's a different type of nanomaterials. So, we can iron based or any type of materials we can use, silica based nanomaterials. These are the basic reactions. So, that is actually happens in this particular process. Okay, so I said what is the role of nanomaterials. So, we are using silica based nanomaterials, ferrosulfuric oxide nanomaterials or zero valent ions that we can use for as a catalyst for this particular fermentation process. So, here's actually this is the role of nanomaterials. So, initially it was zero oxidation state. So, in presence of these nanomaterials in light, so it would be converted, transformed into ions. So, during this fermentation process, so by that way these are the hydrides ions, H plus ions would forms in that particular process that would be converted into hydrogens. By that way they enhance that hydrogen productions. Okay, so here photofermentation process already have discussed. So, here's a table is showing here. So, here different type of nanomaterials. So, silver, gold, nickel, iron sulfates, coppers, ferrosulfuric oxide, ferric oxide, titanium, different nanomaterials, different type of microorganisms in this particular process we can use, and hydrogen's yield increase that amount. So, if we do not use gold or silver nanoparticles in this particular process for biohydrogen production, so you can see by using nanoparticles the yield has increased 61.7 percentage to 67.5 percentage by using gold or silver nanoparticles. So, similarly some other nanoparticles if we can use, that is the feedstocks. So, here ferrous oxides was used anaerobic addition conditions, and here biohydrogen's productions increased close to 70%. Similarly, for others different nanomaterials that also has particular roles for the productions or increase the biohydrogen productions. Now, integrated process I said, that is the dark fermentation and photo fermentations both can be coupled and we can enhance that total hydrogen productions. So, this would be dark fermentation process and this is photo fermentation process. What are the effluents come that would be charged into next steps in the photo fermentation process, and there we can microorganism catalyst. Here also we can use microorganism catalyst. So, here additional slides you have to use, this would be conducted in absence of light. So, by that way you can increase or enhance the total biohydrogen productions. Okay. So, this process actually this coupled of both the process or integrated process, this is dark fermentations process. So, here's what are the organic effluents acids will come volatile fatty acid that again further converted into photo fermentations process, and by that way both the process we are getting hydrogen CO2 in dark fermentations. Let us say 4 moles of hydrogens we are getting per gram of glucose. So, here's 8. So, totals both the process when you are coupling, so we are getting 8 moles of hydrogens per grams of glucose. So, just if glucose is the substrate, so by that way you can enhance totals 12 moles of hydrogens for this particular process. So, actually in dark fermentations process I said, so what are the complex biomass that was used in presence of nanomaterials. So, that would be converted into acetic acid, and in the second steps that acetic acid would be converted into hydrogens. Okay, so here in dark fermentations process this is the bacteria we can use, and in this process this photo fermentations process we can use, and cellulose if it is source of material. So, hydrogen yield 4 to 6 moles hydrogens per moles of hexose. Similarly, some depending upon the carbon source the amount of hydrogens yields that would be vary, also that depends on that microbes, that is microorganisms we are using for this particular process, either it is dark fermentation process or photo fermentation process. Depending upon that the yield of hydrogens also would vary. So, here different type of nanomaterials stabilized. So, here is the yield of that particular process. So, next is the photocatalytic process also I have said. So, different type of photocatalytic reagents we can use. So, that is CDS nanofibers that can used for the fermentations process or electrolysis process, titania activated carbons, platinum titanium activated carbons, that also we can use as a photocatalyst, that would be electrolyzed waters and gives or generates more amount of hydrogens with that process. Okay, so that way we can enhance that amount of hydrogens that is we need for by by degradations of water, at the same time biomass also, as a result overall total hydrogen productions we can improve. So, here it has been shown titania, that is normal titania P25 that was used. So, here's biohydrogen productions was that way. So, with the time, and hence with that 0.58% graphene oxide, graphene reduced graphene oxide was used. So, here's the you can see this composite was used as a nanomaterial for this hydrogen production. So, the rate of productions with increasing times that gradually increase if we add very small quantity of the graphene nanomaterials and with the titania to prepare the graphene Ti2 nanocomposites, that always gives more amount of hydrogens. Then biogas production. So, biogas that is basically composed of methane and CO2. So, with that small fractions of water is also present in the biogas. So, biogas also global biogas productions gradually increase with years, you can see, and different countries also biogas producing. So, this is basically anaerobic digestion process. In that case different type of substrates we can use, and biogas, so I said methane is the main component, with that CO2 is also present and water is also present. So, biogas yields that amount. Okay, so here is the compositions of biogas. So, main component is methane, CO2, and water vapor is also present. So, this is the yield. So, this is the compositions of biofuel. So it actually these biogas productions that depends on the temperature as well as retention time. So if we keep it for longer period of time, so then temperature we need very less amount, and if you go for low retention times, so then you have to go for high temperatures. So low retention times required high temperatures, and low temperature requires high retention time. So depending upon that particular process, we can generate more or less amount of biogas. So depending upon that residence times and temperature. So here this is anaerobic digestion process. So here also a different type of biomass we can use, and that biomass would be digested in presence of nanomaterials, and different type of microorganisms also we can use. So in this particular process actually it is digested for different steps. So here means particularly biomass that would be converted into CH4, that is the main constituents in the biogas. So here 4-step hydrolysis process, acidogenesis process, acetogenesis process, and methanogenesis process. In that process actually this biomass that is more complex materials, that is polymeric material, long chain material. So in digestion process in the first steps it would be converted into monomers in presence of water, that would be react and converted into monomers, smaller components, and then it would convert it into different type of monomer, would be converted into different type of acid, smaller acid, acetic acid, propionic acid, butyric acid, and then those acid components would be converted into acetic acid in this third step process, and then that those acetic acid would be converted into methanes by decompositions. At the same time different type of CO2 and hydrogens also would form, so those also would be converted into methane in this digestion process. Okay, so in biogas production, so here step 1, step 2, step 3 and step 4, so already have discussed. So you can see here large molecules in the step 4 that would be converted into monomers. In the second steps that would be converted into different type of acids, CO2 alcohols that would be converted. In the third steps those whatever the acetic acid means CO2 and hydrogens that was forms with that acetic acid, so that would be converted into acetic acid. In fourth steps acetic acid that is forms in third steps, and at the same time unreacted CO2 and hydrogen that again also would be converted into methane in the fourth steps. So each steps also we can here we can see the biochemical digestion process of biomass to biogas generations. The step was hydrogenations, acidogenesis, acetogenesis, and methanogenesis. By this way, step by step, so organic materials converted into biogas by step process in that anaerobic digestions or that reactors. Okay, different type of carbon nitrogen ratio, carbon nitrogen ratio more than 30, less than 30, that depending upon that materials, any materials we can put it here. Depending upon that also the product also would be generated different means in this particular digestion process. Depending upon that source material, the productions of biogas also compositions will vary. So here's biogas productions process general methods we have shown by considering 4 different steps. So now in these productions, if you want to increase rate of productions of methanes or biogas productions, so different type of metals based, that is nickel, cobalt, iron, platinum nanomaterials we can use, that is encapsulated with the silica support. So that materials we can prepare, we can use that for this biogas productions, increase the biogas productions. Also zero valent irons, Fe3O4, these are the materials very good or effective to increase the biogas productions. Also there are some other materials, that is copper, zinc, ferric oxide, alumina or nano silvers, that decrease the biogas productions. So if you use these are the nanomaterials, so then biogas productions will decrease, and if you use metals or metal oxides based nanomaterials, then biogas productions will increase or enhance. So here's the schematic diagrams. I'm not going to discuss where different type of biomass that we can use, and there's different type of biomaterial nanomaterials we can use to enhance that biogas productions. Okay, so here's these role of nanomaterials for these biogas productions already have discussed. So in anaerobic digestions here also for the productions of methanes or biogas, so those nanomaterials or nanoparticles act as a catalytic agents that for microorganisms, and also alter the oxidation states, promote the transfers of electron during this digestion process, also provide large surface area to volume for this micro, that would help for microorganisms to bind with the active sites and enhance that productions of methanes. Also favors the metabolism process for microorganism or microbial community. Okay, so here you can see in this particular table, see here different type of zero valence metals in irons that was used, also ferric oxide, copper oxides, alumina that was used. So different type of inoculum, so that may be waste activated sludge. So here methane production rate increase when effect on overall process reduce the concentrations of H2S productions, that is reduced, but methane productions rate increased. So when zero valence irons was used for waste activated sludge, okay, so for that the period of means digestion was 17 days. So similarly for other materials also, so depending upon that nanomaterials, inoculum and period of digestion, so depending upon that methane productions rate also or biogas productions also rate will vary. Different type of metal oxides also I said, a few metal oxide, that is copper, zinc or ferric oxide, those inhibit this digestion process, as a result methane or biogas productions that would decrease. So next is the biodiesel production. So biodiesels, there are also for biodiesel production. So here we can use different means oils that may be edible oils or non-edible oils that we can use for this productions of biodiesels. Here to increase the conversions or rate of productions of biodiesels. So here we can use different type of silica, methyl functional group of silica, so that we can use, or zirconia based bifunctional catalyst we can use to increase the yield of biodiesel productions. Also calcium oxide nanoparticles, that also we can use, that is very effective or promising catalyst or nanomaterials, so that we can use for biodiesel productions. Even ferric oxide or silica, that also increase the 97% yield of biodiesel from algal soil. So this is the progress of biodiesel productions, you can see that is gradually increasing. So from 1992 to 2020, so rate of productions of biodiesel increasing, at the same time production different country that is increased. Okay, so this is biodiesel productions, that is basically transesterification process. So in this process actually the reactions that I am going to show, that here this is the glycerol esters that was taken. So this is triglycerides. So here's methanols we have to use. So here's another alcohols in presence of catalyst or nanomaterials, so that would be converted into alcohols or glycerol from triglyceride to this, and this is fatty acid methyl ester that would form. So that is actually biodiesel. So means triglyceride that would be converted to this R1 R2 converted into methyl esters actually. So that is biodiesel. So in this particular process means triglyceride we can convert it into fatty acid methyl ester or biodiesel. So in this process different type of metal oxides, by oxides, barium, strontium, magnesium oxides that we can use in this catalytic process for conversions of biodiesel production. So this is the process, I am not going to discuss more details on that. That is basically reactions or reactors where we can use this triglyceride, and there we can put acid or a base at the same time some solvents and some nanomaterials, metal oxide, that is calcium oxide, strontium oxide, and for this particular productions of biodiesel. So here you can see, so this zinc oxide nanoparticles, sodium hydroxide, and that was mixed, and here's methanols, and this TPA was added. After that some temperatures we have to maintain, and then we can get biodiesel, and after different separations process distillations we can get biodiesel. So here is this zinc oxide nanoparticles that is very effective, that we can use for the biodiesel productions. Okay, even I said that calcium oxide also very effective, ferric oxide that is dispersed in silica, that nanomaterials also very effective for biodiesel productions from algal soil to biodiesel conversions, and this material is very effective. So, okay, so here's the summary of this means biodiesel production. So different type of nanomaterials, calcium oxide, zinc oxide, TPA, IGO, strontium titanium oxides, these nanomaterials, and these are the feedstocks we can use to waste cooking oils or whatever. So the yield increase, so calcium oxide nanocatalyst that is very effective and increase good amount of yield for this biodiesel productions. Similarly other materials also we can use for the biodiesel productions. Okay, so here's bioethanol production. So here's bioethanols, that is another biofuel. So this means biomass to biofuel productions in the first generations, biodiesel ethanol productions, second generations ethanol productions, and third generations ethanol production. So here's bioethanol initially or first generations usually different type of edibles materials used to produce these ethanols. In second generations bioethanols, there are different type of rice or corn straw instead of edibles materials. Non-edible materials are being used, and then in third generation different type of algal biomass that can be used for productions of bioethanols. Okay, so here's with that different type of microorganisms also we can use, and immobilized cells we can use, and that can be immobilized in particular surface. And with that, if we increase the productions of this bioethanols from algal biomass, so then different type of nanocatalyst or nanomaterials also we can use that would enhance that productions of bioethanols. Okay, so if we our target product is bioethanols and source materials is algal biomass, so these are the microorganisms we can use, and also with that different type of nanocatalyst or nanomaterials we can use, so increase the productions of bioethanols. This is the year wise bioethanol market. Okay, so here I am not going to discuss the individual steps how the bioethanols is produced from different waste biomass by fermentations process, and then after distillations we can get 99.6% so dehydrated ethanols, or the concentrations we can increase. So when fermented that biomass, so then 0 to 10% concentrations would be here, and after that by distillations we can increase the concentrations 10 to 90%, and then again further dehydrated we can get absolute alcohols or 99.6 bioethanols that we can produce. Okay, so here different steps. So here you can see this tables. Here's different type of materials, nanomaterials, ferrous oxide, manganese oxides, methyl silicates, or this type of materials, cobalt iron based materials we can use for the productions of bioethanols. So others materials also nickel based, zinc based also materials we can use. So depending upon a particular nanomaterials, the productions of bioethanols that would increase. So depending upon source and the nanomaterials, a specific nanomaterials we can increase that, whether we need particular bioethanols or biofuels, so we can enhance that. So this is the summary of overall biofuel productions, hydrogens, biogas, bioethanols or biodiesel productions. There's nanomaterials or nanoparticles we can use for this particular biofuel productions. Here biohydrogen productions, these are the nanomaterials we can use, and this is the substrates, and this is the outcomes. You can see production rate will increase. Similar for biogas, these are the nanomaterials we can use, these are the source or substrate feedstocks we can use, and this is the experimental conditions. So we have to maintain for this particular process, and then we can increase the biogas productions we can enhance. Similarly for bioethanols, these are the different nanomaterials we can use, and we can enhance that bioethanol productions rates. Similarly for biodiesels also, these are the different nanomaterials or nanoparticles we can use with a specific substrates, and this is working conditions and experimental conditions, and under these conditions we can increase or enhance that yield of biofuel productions. Okay, so this is the different carbon based materials also that also can be used. Okay, so this is the summary of overall biofuel productions and biohydrogens, biogas, biodiesels and bioethanol productions. There's different type of biomaterials would be the source, and with that different type of nanomaterials, that is in terms of metals, metal oxide, carbon based materials, or different photocatalytic materials that individuals or combined we can use as a catalyst, so that would enhance that biodiesel biofuel productions. So that is the role of nanomaterials, so that would enhance that overall biofuel production. So this is the use or another applications of nanomaterials from chemical engineering point of view. So okay, so today is up to this. Thank you.